Hello, students. Hello. We did almost like all the theory parts about your lenses and the practical parts also included in that one. Today our aim is to do human eye and a simple microscope, that part altogether. So we have to do some of the questions as well. And today's student count is very low. I don't know why they have taken the vacation so early. Don't know when they have the exam within like 9 months, they have no intention of joining. So they always try to enjoy vacation like Christmas and all. I don't know why. When the exam is around the corner, you can't enjoy those things. Your only enjoyment should be exam. Somehow, unfortunately, students are behaving like that. It doesn't matter. As long as any single student there in the class, I continue with him or her with the theory. Okay, human eye. Open a very big topic and write human eye. Human eye. By the way, Lamai, in the last week, did I give you any note regarding human eye? I just asked you to read the note. And did I give any note to you? Until to what part did I give you? Can you send me a WhatsApp message about that last note? So take a photo of the last notes, last week thing, and just send me the last note you have written, because you are not supposed to write the same thing again for twice. Can anybody just send me a message to WhatsApp? Anybody, quickly take a photo and quickly send me. Okay, Lama, enough. So we can continue with the long sightedness. Right, students. So I hope you have kind of like read this material according to human eye and all. So there are some kind of like very important information over there. And it all cover up with like all 4 pages about the theory. So that will give you a really good idea about how it behaves. Okay. So now write another subtopic under that, human eye. For the new joiner, just keep a 1 page, complete 1 page for the last week's note about the human eye. So continue from that point. Write a subtopic, long sightedness. Long sightedness. long sightedness, right? Long sightedness. Okay. As I told you in the last week, human eye consists of a certain lens. That lens is a flexible lens. So the lens can just adjust so as to getting thinner or thicker, just change the focal length. Somehow, long sightedness, those people can see the things coming from far away. They can see the far away objects. As we consider like the long means, what is the longest thing a human can see? Something at infinity. So we consider like sun, moon, and planets, and those things have a certain mountain or something very long distance away, considered like a light rays coming from infinity. We consider the light rays are coming nearly parallel. Nearly parallel. Okay, nearly parallel. So it is considered like infinity. You can see sun, moon, and those things, and very far away things. Those people suffering from long sightedness can see clearly. That means it will form a firm image on the retina like this. This can see what far away things clearly. Clearly can see far away things clearly. But the problem is when you see something closer, so when the light rays coming from a close by object, close by means light rays have more tendency to reach the eye with a bigger angle like this. When the angle is bigger, that means it is more diverted. Now the bright rays are more diverted like this. Divergence. So very diverted means the eye lens, if the eye lens is unable to bend it like this way, this is what we expect from a nearby objects. About D, that means the minimum distance of distinct vision. Close by means normally for a 25 centimeter for a regular person, 25 centimeter away from human eye. So it is we consider like what least distance. So here the thing is, if it get bent like this, no problem. But the problem is those who suffering from long sightedness, they can't bend the light ray like this. Actual ray will just focus behind retina because why? It is unable to bend. It is unable to bend. This is where the image forms. Actual cases, it forms just behind the retina. Now there is a big problem. Why? It was supposed to form exactly on the retina, but it doesn't form. It forms behind the retina. This is the problem. On the retina, it will form certain vague image, like very unclear one. Can you understand what I'm saying? Yes or no? Ulang ho gaya, neta na gaya. Students, yes or no? Okay. However, copy this one. Image form behind retina. This is a problem. Problem. Oh yeah, that is a problem. Mark it. That is a problem. Okay, Raman? Okay. Image form behind the retina. This is a problem. Quickly draw it. In the human eye case, we have to learn these things. Firstly, identify how the image correctly formed. Then we have to identify what is the problem. So under the problematic eye even, this part is clear. The next part is the close by. We have to understand the close by things. Send the radius like this wide apart. The eye is unable to bend light. Bend light. Okay, mark it. Okay, Lamai? Got it? Got it? Mark it, mark it, mark it. Okay. Did you finish drawing? Did you finish drawing? Okay. Now, right, the actual problem behind this can be uh, can be eye lens is a thin one. There are two reasons. Can be, write this in a new line. There are two reasons. There might be two reasons. There are two reasons. Number one, the eye lens might be a thin one. Eye lens might be a thin one, and it is unable to bend the light. Bend the light from close objects. Bend the light from close objects and focus on retina. Focus on retina. Okay, that can be the problem. Thin lens. Okay, thin lens. Lens is thin. You can still use the same diagram and write thinner lens. Draw this again and thinner lens. This is the reason. Thinner lens is the reason. Quickly, thinner lens is the reason behind this. I'll draw this very quickly. Now write in a new line quickly. Thinner lens, unable to bend. Now write. Oh, the second point. Eye globe might be a shorter one. Eye globe diameter might be a shorter one. Right? If this is the size, if it gets squeezed like this, this is the ideal size of the diameter we expect to have. But if it gets shorter, it is not going to work well. Okay, this is the ideal size. Ideal size. If it is in the ideal size, it will focus. Yes, it will focus. If the eye is like this much, this is what expected value, but the eye has real size like this. expected size, real size. Okay, now the eye globe is a very short one. Rays are coming. It was supposed to focus on here. It was supposed to focus on there. So lens has nothing to do with. Lens will try to do that. But the eye has a very short lens. Eye is a very short one. So it can't form the image. Here the problem is what? Short eye. Okay, mark it. If the eye sphere is a very short one, you can't have a clear image formed on the retina. Okay, mark it. This is all about the long sightedness. Okay, there are two reasons you should know. Mark it quickly. Okay, lamai. Okay, lamai. I hope you copied this. Draw things faster. Okay, if you just know, you can see the things clearly from the far away. When it is close by, you know now it doesn't form. You know the two reasons. What are the two reasons? One can be a thin lens. The other thing is, don't try to remember by heart. කටපාඩම් නම් කරන්න එපා. මට තවම කටපාඩමින් මතක නැහැ. ඇත්තම කිව්වොත්. 9 වසරෙත් ඕක තිබුණානේ. මම 9 වසරෙත් ඉගෙනගෙන තවම මට ඒක කටපාඩමින් කියන්න බෑ. මම මේක ඇඳලා ළඟ ඉඳන් එනවනම් මෙහෙමයි එන්නේ. නැත්තම් වෙන්නේ නැහැ කියලා ඒ වෙලේට හදලා තමයි ගන්න. මට නිකන් ලෙසන් එක උගන්වන්න කලින් කවුරු හරි ඇහුවොත් එහෙම මේ සර් ලොන්గ్ සයිට්නස් වලට ලෙන්ස් එක මොකද්ද වෙන්නේ? මම ඩයග්‍රෑම් එකක් ඇඳලා ටාර් ගාලා තමයි කියන්නේ. මොකද මම කවදාකවත් කටපාඩමට ඉඩ තියන්නේ නැහැ. ලොජිකලි ගන්න පුළුවන් දේ. මොලේ ඉඩ හරි සීමිතයිනේ. මම ඒවා try කරන්න. මේක අඳ ගමන් පේනවා bending away. So the eye sphere is unable to bend. That's what happened. Unable means it bends beyond. That is the reason. Okay. We identify the lens can be a thin one or the eye can be a short one. Right? ගොඩාක් කොට හැක් තියනවා නම් දුර පේන. Okay. Long sightedness. Okay, Raman. Now the problem is, if we know the problem even, now we want to eliminate the problem. How? How are we going to do that? Now we know the problem that we can't bend the light rays. Long sightedness means the person can see the far away things. Can't bend. It is trying to go like this. So the problem you can create, solution you can create is, you can bend certain lens to bend this light. It is traveling like this. If you can make the light parallel, this eye lens can easily bend it with no effort. if you can make this light parallel before coming to the eye, you can introduce certain lens. So that lens will bend the light and make it parallel. If it becomes parallel, that will be able to directly focus on the retina. Okay, that is why I didn't erase this image. Can you see? The parallel light is focusable. So if you can make this light ray for parallel after running through a certain lens, so if you are bending something, that means diverging ray, you are going to make it parallel. That means you have to bend towards. That means the lens should be a what type of lens? Definitely a convex lens. This lens should be a convex lens. Mark it. By wearing a convex lens, suitable convex lens can give a solution to this. Can give a solution to this. Solution to this. Solution to this. Okay, Ramai? Can give a solution to this. Okay, Lamai. Quickly. That is the remedy. That is the correction method. Okay. Now you should remember one thing. Other one is short sightedness. Short sightedness means the person can see the things close by, but when he see the things far away from him, can't see. Can't see. So that is the problem. So how to give a cure to that one? How to get out of that problem? How to get rid of that problem? How to bounce back from that? How? How are we going to do it? අපි කොහොමද ඒකෙන් බේරෙන්නේ? Huh? There is only one way. There is only one way. How? By wearing a convex lens. Now the problem is short-sightedness. Is short-sightedness. That means the person can see the things clearly. Okay. Now the next problem is short-sightedness. I'm not going to give you any note for this one. You have to write your own note for the short-sightedness and send me the written notes as photos or PDF. But I will explain you that part. Okay, I will explain you. I have no intention to give you a note because you are in A-level class, advanced level. The opposite thing you can easily imagine. Only remember one thing. Other one is completely opposite. That means this person, long-sightedness means parallel rays can't focus on here, means parallel ray is the easiest one to bend. That means he bends more. The problem is he bends more. Long-sightedness. Sorry, short-sightedness. Short-sightedness means he bend it short to the eye. So this is a problem. It won't form a right image on the eye. It will be a weird image. Infinity does not, so this is the problem. But when an object is close to the eye gets well widespread rays from here. The eye lens is exactly suitable to bend this exactly on retina. Now you can bend the thing exactly on the retina. Okay. Now you can just bend it on the retina. Right? Can see closer ones, closer objects clearly. Clearly. Okay, mark this. Mark this. No, don't mark, don't mark, don't mark, don't mark. I asked you to write your note. So can see the things clearly. Don't write. Okay. Now there can be two problems. This can occur due to two reasons. Can you tell me the two reasons? අරකෙම අනිත් පැත්ත කිව්වා නම් ඒත් හරි ඒත් හිතලා කියන්න. What can be the two reasons? Huh? So exactly opposite to the other one. Okay, how would look at short-sightedness people can't see longer things. It will focus like this. In the previous one, focus behind. This one focus before. Shorter things can see easily. In the previous time, he couldn't see the shorter things. Now he can see the shorter things very close by ones easily. Now it can cause due to two reasons. What are the two main reasons? Sometimes it might be a combination of both reasons or one reason together. What are the two main reasons it can be? Tell me. Yeah. මොනවද ඒ reason දෙක? ළමයි. What are those two reasons? මොනවද ඔය reasons දෙක? Huh? Yes. Yes, you are correct. Others, can't you imagine? Just the opposite case. If it bend more, that means the thick islands bend more. I show you that with the demonstration, නේ? කරලත් පෙන්වන්නේ ළමයි. එදා මම ඕවා කරලා පෙන්නුවේ හේතුවක් ඇතු. රීසන් එකක් එක්ක තමයි කරලා පෙන්නුවේ. ආයෙත් ඕනම් කරලා පෙන්නන්න. Okay, I'm going to show you this once more. Once more. Okay. Okay, firstly, let me just show you with the medium lens. Medium size lens. Okay. You can see there are three different size of lenses, right? Thicker one, medium one, the very thin one. I will get the medium one and try to draw the diagram. So these three are kind of like parallel light rays. Have a good look at clearly, closely. These three are kind of parallel light rays. You can see now after the bend occur, it will bend exactly on here. Let me mark the position of the lens and stuff. I will firstly, okay, it is not nice parallel enough. Parallel enough. I will initially draw the position of the eye like this. Okay, it will make a bend. So this is where it is going to bend. Okay. If the eye has a lens like this, and this is what a healthy eye it may look like. A healthy eye. On a healthy eye, it will exactly form where rays are exactly going to form on the retina, right? Exactly going to form on the retina like this. Can you understand? This is what our expectation, right? Now I am going to show you that with a very short eye. Okay. Now my eye sphere is not that longer. It is going to be a shorter one. Short, yeah, short eye. Now what would happen? Short eye. You can see the light ray is going to focus somewhere behind it. See, little bit behind. So will it be able to see the light rays clearly? It is supposed to exactly point on here. Now the other reason is the eye sphere is in the correct size. It is in the correct size. No problem. But I will have a very thin lens. Thin lens. Okay. Now I'm going to show you the same thing with the thin lens. This is the lens I earlier used. Now this is the new lens. See, this very thin. Have a good look at. Now I use the thin lens, and you can see the light ray actually converge somewhere here. That means it is unable to produce the expected light ray. Okay, what happened to this one? Am I using the wrong? Oh, sorry, wrong one. Okay, see, light rays are produced exactly on just that point. See, point. So that means I can't see. That is about the long sightedness, all caused because of why thin lenses. Okay, now it is in the ideal size. Ideal size, and it can be a what type of lens? A thicker one. Now the problem can cause due to a this is what the original size. This is what a thicker one. See, සෑහෙන මහතයි. Let's see what would cause. කතා දෙකක් නෑ. මග නතර වෙන්නේ. So it will cause the ray just in between the path between the retina and the eye lens. So that is a big problem. See, that is a big problem. Or the lens can be in the ideal size. Lens can be in the ideal size. And if the eye globe is a longer one, see, this is where the exact one it can be. So now I'm going to keep the same usual lens there. It will form the ray exactly on where it should be. But the eye globe is a longer one. Now it will just focus just behind the lens, original place where you expected it to be. So this is all. What about what human eye and the ray behavior? So watch this part 2 to 3 times. You will definitely understand what are the two possible problems with this one. Give me a 1 minute to Okay, Ramai? Right. I hope you understood. So the short-sightedness case, it can caused by a long eye sphere or a very thin, very thick eye lens. How to avoid that problem? You can avoid that problem very easily by just placing but parallel light ray is the only thing you can't see because it will just get uh, seen like this. But if you can send the light ray as if it is coming from where? As if it is coming from a very nearby object, so you can do it. What you have to do is you have to kind of like diverge this light ray, diverge as if it is coming from D, then it will be able to form the image exactly on the retina. So this is how you correct the problem. How? By wearing a suitable concave lens. By wearing a suitable concave lens. Understand? Do you understand it? Say yes or no. Say yes or no. Okay. Right, Lamai. Keep sufficient space to you to write your note about the short sightness because it is A level. Just the opposite things you have to write. So now let's quickly move on to some questions given in the system here. Oh God. Give me a minute. Right. Now let's do questions. By the way, I have to give you another small note about that. Keep sufficient space to write that short sightedness note. And very quickly add what I'm saying now. Now write diopters. Diopters. Right? Diopters. A subtopic. Diopters. 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 What is the meaning of a diopter? The meaning is none other than, write this up, the way of measuring power of a lens. Power of a lens in optometry. Optometry. What is the meaning of optometry? Eye related medicine. Eye related medicine. Open a bracket and write medicine. Optometry is diopters. Okay, we know the regular case. What is it? 1 over f. This is how we measure. But in diopters, power in diopters is what? Minus 1 over f. I will tell you why did I include the sign of minus here. Sign of minus here. Diopter. The reason is In regularly, we consider focal length of a regular one. Convex lens, we consider it like having a focal length of negative. And for a concave lens, we consider it like having a focal length of positive focal length. But in medicine, optometry, we use what? This one as positive. In optometry, we use this one as positive, this one as negative. Okay, sign convention is completely inverted. So, if you want to convert a focal length, we normally apply the focal length of the convex lens as negative. That negative and the negative sign in front will act together to give the final result of positive. Because when you multiply negative and negative, the result is positive. Here, positive and negative this sign, the result is negative. Understand? That is the reason why we put a negative sign. You don't know this anything, just mark it. Every length is measured in meters. If it is centimeter or millimeter, you have to apply real suffix or prefix just in the top, and I will show you an example. A convex power of a convex lens with focal length of 20 centimeter. Okay, what is the power? As a question, example, write this and draw this in optometry. Write that in optometry. In optometry. Okay. So let's apply. How to get the power? Minus 1 over what? 20. That means you have to multiply by 10 to the power minus 2. And there is a minus sign here as well, because in regular physics way, we use this as minus, convex lenses as minus. So what is it? It is going to be positive. This goes up. So that is why I told you, if you put the power on top, it will be easier. 100 over 20. So you will get the power in diopters as what? Positive 5D. Do you understand this? Do you understand this? Do you understand this? Guys and frogs, can you understand it?
Yes, sir.
Okay, copy that. Copy that very quickly. Let's go. Now we have to do the questions given here. Okay. Questions given here. And let's quickly complete that part and go for the simple microscope. Quickly do that. Quickly copy this. Okay, Ramai, I think you had enough time to copy it. Had enough time to copy it. So just give me a 1 minute.